Good morning to all of you. So today here we're discussing the module 1. It's on basic structure of computers. So the syllabus is as of this: computer types, functional units, basic operational concepts, bus structures, software performance, processor clock, and basic performance equation. Now let us look at the computer types. Look at the basic structure of computers. And that the first concept is computer types. What exactly this means is we have a digital computer which is also called as a simple computer, and it is the fastest electronic calculating machine that which is going to accept the information in digital form, and it will process the data according to the sequence of instructions which is stored in the internal storage and provides the process information to the user. So the computer is very simple. It will take the data in digital form, process it, and store the end result in an output form. All right. So the sequence of instructions stored in the internal storage are called as computer programs, and the internal storage is called as computer memory. In this way, we can able to categorize this computers of different types. So if you see this here, we have 4 different types of computers. The first one is personal computer, second one is based on servers and enterprise, third is supercomputers and grid types, and fourth is embedded computers. As we have seen in the earlier class, what does a personal computer mean? So which will have widespread of use. It can be used in homes, it can be used in educational institutions, it can be used in business processing, and it will be primarily used for the individual purposes. And the main application of this personal computers is based on general computation. It can be used for documentation purpose, or it can be used for CAD designs, or it can be used for entertainment and internet browsing and so on. See this one, this can be categorized into three different versions: desktop computers, workstations, or portable or notebook computers, as we have seen in the previous class. So whereas in case of notebook computers are operated based on battery based, and the left side one you can see the desktop computers. So this way the computers have been classified, and further this classification is continued based on servers and enterprises. So where if you want to use larger amount of data, we need to use servers because the personal computer cannot able to store huge amount of data. So we have to use the servers to store the data, and this servers can be in a private domain or it can be a public domain, whatever. So if you see this diagram here, you can able to understand, you can able to see the server here, which is being connected with the local computers, all these local computers and local server here, the global server, which is being protected with a firewall. If you are trying to connect to the outside network, we are able to get in this manner. We'll move on further with the next type of computers, which is supercomputers and also grid computers. Supercomputers are most expensive, as we know that it has the best computing capabilities, and it will be useful for us in finding or forecasting the weather. It will be used in engineering design, simulations, and scientific works. So this is the setup of servers that are located or of supercomputers. Okay, this is about the supercomputers. And if you look at the grid computing will provide the most cost-effective model. So what they are trying to do is they are trying to collect all the computers and they are trying to connect it hand to hand. So like we cannot able to do our job alone. We take help from our friends and we take help from our family, so that we can join hand to hand and we can able to achieve success. Similarly, the grid computers also is going to use this kind of approach. So what they do is they use different computational capabilities with the different disk storages, and in that they are trying to connect them in a proper manner so that all of them can be combined to a grid, which we can able to manage the grid, and we have a grid coordinator and we have a grid computing resources. So this way the distribution is going to happen among the users, and we can able to compute the larger applications, and we can able to compute it in a better way. Similarly, see this diagram here. If you observe each and every portion, let us say here four partitions are there. Each and every portion here, we can able to see that we have the computers located, and those computers are connected in a form of a grid. And to connecting all these computers, we have the control node which is going to connect the computers, or the personal computers. So this is the grid type structure, which is the most cost effective one. And further, we have a computer types of embedded computers. So these embedded computers are integrated into a larger device or system in order to automatically monitor and control physical process. So what this computer is going to do, why we call it embedded? Embedded means what? So where we are going to integrate all these things. So we're going to integrate the software and the hardware part. So that's why the name embedded. Okay, and those who use these one for specific purposes rather than general purpose. So embedded computers are used for a specific purpose. Let us say to do a repeated task again and again. We use this. If you have to take an example of a coffee vending machine, just to press the button, you get a coffee. So that's the task which is being done repeatedly. It's not a general purpose. So in that kind of applications where you want to do the task repeatedly, we use these embedded computers. So typical examples of these embedded computers are like home automation and appliances related to telecommunication products and vehicle communication. So these were the. So if you see this diagram here, this is the PCB mounted here. Over there you can see this QIP structured processor. This is your embedded controller, right? So, and we further also have the classifications of these computers. So based on the usage, so the world is moving very fast, rapidly, and advancing its technologies. And we are trying to move towards the cloud computing. Now you see, you take an example of your mobile phone, where your data, how much data will be there in that, it will not be sufficient. You will take the help of the cloud. So all the apps what you are installing, all the photos what you have, everything can be backed up in the cloud. So with this cloud computing model, where we can able to work in a distributed manner, and the server resources also can be used by the individuals independently, and the computational needs can be achieved. So but it needs internet for the connectivity, and also this cloud hardware and software will provide the services. So based on the services what they provide, they're going to charge for it. So this policy is called as pay as you use policy. So that way the cloud computing is going to happen. So if you see at the center of this cloud computing part, we have the servers, and to the left side we have a virtual desktop and software platforms what we have, and the applications and storage of data. All these are a part of a cloud. Now this cloud is going to compute from one end to other end. We have a router and we have a switch. If you want to communicate to the cloud computing, if a printer want to get a document printed, or a mobile phone want to send a message, or it can be a notebook, or it can be a laptop, or it can be a desktop. Any one device want to communicate to other device, they can able to connect in a distributed manner, so that the functionality of this will uh, remain same with respect to the data transmission, or with respect to the any of the image transmission and so on. So this way the cloud computing will be an effective manner. In the storage, if you use only one GB, they'll charge you in a different manner. If you use 5 GB, so that it will be in a higher end. So which means how much data you want to store in that cloud, that much amount they'll be charging relatively. So that's proportionally, if more amount of data, more charges they'll be imposing on that. So this way it's been working on. And in the next section, we'll try to discuss on the functional units of the computer organization part and architecture.